1.2 Laplace transform of elementary functions. Laplace transform of A, where A is a constant. Laplace transform of A equal to integral of 0 to infinity e power of minus st A, put here A dt. A is constant, take outside A, integral of 0 to infinity e power of minus st dt. A as it is, integral of e power of minus st is e power of minus st divided by minus s. So limit is 0 to infinity. Minus 1 by s take outside, so minus a by s inside the bracket. Apply the upper and lower limit for t. So e power of minus s into infinity is e power of minus infinity minus lower limit e power of minus s into 0 is 0. So e power of 0 equal to minus a upon s e power of minus infinity is 0 minus e power of 0 is 1. Laplace transform of A equal to minus minus plus a by s into 1 is a by s, where s is greater than 0. Otherwise, any value becomes 0 is nothing but infinity agogbidate. So therefore, Laplace transform of A equal to a upon s. If ಅಂದರೆ ಇಲ್ಲಿ ಎಸ್ ವ್ಯಾಲ್ಯೂ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಇರಬೇಕು, ಅದರ್ವೈಸ್ ಇನ್ಫಿನಿಟಿ ಆಗುತ್ತೆ ಅಷ್ಟೆ. ಇಫ್ ಎ ಈಕ್ವಲ್ ಟು 1, Laplace transform of 1 equal to 1 upon s. So this is first elementary functions. Next, second one, Laplace transform of e power of at equal to Laplace transform of e power of at is integral of 0 to infinity e power of minus st. F of t is nothing but e power of at dt equal to integral of 0 to infinity. So here base is common, take common e. Index is different, but t is common. So minus inside the bracket s minus plus minus a. T take common dt equal to integral of e power of minus s minus a is nothing but e power of minus s minus a into t divided by minus of s minus a. So limit is t equal to 0 to infinity. Here minus 1 upon s minus a take outside. Then apply the limits for t. So upper limit minus of lower limit. E power of minus s minus a into infinity is e power of minus infinity. Minus lower limit e power of minus s minus a into 0 is e power of 0. Equal to e power of minus infinity is 0. E power of 0 is 1. So minus 1 upon s minus a into minus 1 is plus 1 upon s minus a. So therefore Laplace transform of e power of at is 1 upon s minus a. Here s value is greater than a. Otherwise it is if it is s equal to a, then it will be 0. Then Laplace transform of e power of at becomes infinity ಆಗಿಬಿಡುತ್ತೆ. Otherwise less value, negative sign ಬರುತ್ತೆ ಅಷ್ಟೆ. So that's why s, keep it s value is greater than a. Next, third elementary, Laplace transform of cos hyperbolic of at. cos hyperbolic of at, Laplace transform of cos hyperbolic of at equal to Laplace transform of cos hyperbolic of at. Formula we know that e power of at plus e power of minus at divided by 2 equal to 1 upon 2. Take outside Laplace transform of e power of at plus Laplace transform of e power of minus at. So previous results, we know that from the previous results, Laplace transform of e power of at is 1 upon s minus a. And Laplace transform of e power of minus at is 1 upon s plus a. Take LCM, we'll get 1 upon 2 equal to, otherwise I take butterfly method, s plus a plus s minus a divided by s minus a into s plus a. So plus a minus a cancel out, s is 2s, 2 cancel, and here s minus a into s plus a is s square minus a square. Then Laplace transform of cos hyperbolic of at is 2 divided by s square minus a square, where s greater than a. Next, fourth elementary function, Laplace transform of a sine hyperbolic of at. Laplace transform of sine hyperbolic of at is Laplace of sine hyperbolic of at. Formula we know that e power of at minus e power of minus at divided by 2. 1 upon 2, apply the linearity power property here. Laplace transform of e power of at minus Laplace transform of e power of minus at. 1 upon 2, Laplace transform of e power of at is 1 upon s minus a, minus Laplace transform of e power of minus at is 1 upon s plus a. Take LCM. So s plus a minus of s minus a divided by s minus a into s plus a is s square minus a square. Then here pluses minuses cancel out, minus minus plus a and a is 2a. 2 cancel out, a divided by s square minus a square. So therefore Laplace transform of sine hyperbolic of at equal to a divided by s square minus a square, where s greater than a. Fifth elementary function, Laplace transform of cos at. Laplace transform of cos at equal to integral of 0 to infinity e power of minus st cos at into dt. Using this formula, integral of a power of at cos bt dt equal to e power of at divided by a square plus b square into a cos bt plus b sin bt. We have Laplace transform of cos at equal to, so here a will be minus s and b is a. Put or substitute, a is minus s and b is a. So e power of minus s divided by minus s whole square plus b a square minus s cos at plus a sin at. So limit is 0 to infinity. Then 1 upon s square plus a square e power of minus st minus s cos at plus a sin at. So t value is 0 to infinity. Next 1 upon s square plus a square into, so apply the limits. First you should apply the upper and lower limit. Upper limit e power of minus infinity becomes 0. 0 into anything is 0. So upper limit is 0. Minus lower limit e power of 0 is 1 minus s cos 0 is 1. A sin 0 is 0. Next minus minus plus 1 into s is s divided by s square plus a square. Laplace transform of cos at is s divided by s square plus a square, where s is greater than 0. Next sixth one, Laplace transform of sin at. Laplace transform of sin at equal to integral of 0 to infinity e power of minus st, then sin at dt. So using this formula for this, integral of e power of at sin bt dt equal to e power of at divided by a square plus b square into a sin bt minus b cos bt. We have Laplace transform of sin at equal to, so wherever a is there, put minus s, b is nothing but a. E power of minus st divided by minus s whole square is s square, and b is a. So a square minus s sin at minus b is a cos b is a t. So limit is 0 to infinity. Then minus sign take outside, minus 1 upon s square plus a square, e power of minus st s sin at plus a cos at. Limit is 0 to infinity. Laplace transform of sin at equal to minus 1 upon s square plus a square. So apply the limits. First you should apply the upper limit. E power of minus infinity is 0 minus lower limit e power of 0 is 1, s sin 0 is 0 plus a cos 0 is 1 minus 1 into a, so that is a divided by s square plus a square. So here minus minus plus 1 into a is a. So therefore Laplace transform of sin at equal to a divided by s square plus a square, where s is greater than 0. Next, seventh elementary function, Laplace transform of t power of n. So definition and properties of gamma function is a prerequisite. So it's all ಮಾಡೋಕ್ಕೂ ಮುಂಚೆ, so gamma function definition and properties, it's very important. Laplace transform of t power of n equal to integral of 0 to infinity e power of minus st t power of n into dt. Put st equal to s, then t equal to x divided by s, cross multiply. So we'll get t equal to x by s. Here differentiate with respect to x. So s into dt equal to dx. So cross multiply by s, s na cross multiply ಮಾಡಿ. When t equal to 0, in the limit 0 to infinity alla. So when t equal to 0, put 0 here, then 0 into s, otherwise s into 0 is 0, then x equal to 0. When t equal to infinity, so infinity into s is infinity, so then x equal to infinity. So x vary from 0 to infinity. When t equal to 0, x becomes 0. When t equal to infinity, then x will be infinity. Therefore x vary from 0 to infinity. Now Laplace transform of t power of n equal to integral of x vary from 0 to infinity e power of minus x, means st value is x. Put x value here. F of t value is t power of n. T will be x by s to the power of n. Actually we know the formula for Laplace transformer. Laplace transform of f of t equal to integral of 0 to infinity f of t into e power of minus is, actually Laplace transform of f of t is integral of 0 to infinity e power of minus st f of t into dt. f of t place ನಲ್ಲಿ ಏನಿದೆ tn. t means x by s, x by s to the power of n. e power of minus st ಬರಿಬೇಕಲ್ಲ, ಆದರೆ ಗೆ ನಾವು ಅಸಂಪ್ಷನ್ ಮಾಡಿದ್ದೀವಿ x ಅಂತ ಬರೀರಿ ಇಲ್ಲಿ. dt is dx by s. So here s power of n, here s power of 1. Take outside 1 upon s power of, means base is common, s common ಆಗಿದೆ, but index is different. Here n, here 1. So common for base s to the power of n plus 1. Integral of 0 to infinity e power of minus x, x power of n dx equal to 1 upon s to the power of n plus 1. So from the gamma function, the integral of 0 to infinity e power of minus x, x power of n into dx is nothing but gamma of n plus 1. So Laplace transform of t power of n equal to gamma of n plus 1 divided by s power of n plus 1, where n is a constant. Remarks. We know that gamma of n plus 1 exists if n is a positive real number or n is a non-negative integer. Hence, the expression for Laplace transform of t power of n is valid for n belonging to these categories of n. We know that gamma of n plus 1 equal to n factorial if n is a positive integer. Therefore, Laplace transform of t power of n equal to n factorial divided by s power of n plus 1 if n is a positive integer. We shall establish this result without the involvement of gamma function. ಇದಕ್ಕೆ ಗಾಮಾ ಏನು ಬೇಕಾಗಿಲ್ಲ, ಅವಶ್ಯಕತೆ ಇಲ್ಲ. If n is a positive integer, directly you should write the n factorial divided by s power of n plus 1. If it is a positive real number, okay, not an integer ಅಲ್ಲದಿದ್ದರೆ gamma of n plus 1 divided by s power of n plus 1. So use this formula. If it is not an integer ಅಲ್ಲದಿದ್ದರೆ, like ಬೇರೆ values ಇದ್ದರೆ, so using this formula, if it is a positive integer, use this formula. Next, eighth elementary functions. Laplace transform of t power of n, where n is a positive integer. Laplace transform of t power of n equal to integral of 0 to infinity e power of minus st. F of t is t power of n into dt. So here f of t is polynomial. Take here, interchange these functions. First you should write t power of n, next is e power of minus st into dt. Next, integrating by parts. First function as it is, integral of second function is e power of minus st divided by minus s, limit is 0 to infinity, minus e power of minus st the second function. Apply the integration for this. So integral of 0 to infinity e power of minus st and minus s here dt, and take differentiation for this. So t power of n ಗೆ differentiate, apply the differentiation for this ಅಂತ ಹೇಳಿದ್ರೆ n into t power of n minus 1. So here in this first term 0, because infinity to the power of n, okay, infinity, e power of minus infinity is 0. So 0 into anything is 0, 0 into anything is 0. So this is upper limit, minus lower limit t equal to 0, put 0 wherever t is there, so that there you apply the 0. Substitute the 0 here. 0 power of n e power of 0. E power of 0 is 1, but t value is 0. 0 into anything is 0. So upper and lower limit cancel out. ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಅಪ್ಪರ್ ಲಿಮಿಟಿಗೆ ಇಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. e power of minus infinity is 0, but lower ಲಿಮಿಟಲ್ಲಿ 0. 0 power of n ಇಲ್ಲಿ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ second term minus minus plus n divided by s, take outside, integral of 0 to infinity e power of minus st and dt here t power of n minus 1. So next Laplace transform of t power of n equal to n upon s. So this is nothing but it's similar to the Laplace transformer formula. So therefore Laplace transform of, instead of ft, should write this one, okay, f of t is t power of n minus 1. So therefore Laplace transform of t power of n equal to n upon s into Laplace transform of t power of n minus 1. Similarly, Laplace transform of t power of n minus 1 equal to n minus 1 divided by s into Laplace transform of t power of n minus 1 is n minus 2. Next, similarly, Laplace transform of t power of n minus 2 equal to n minus 2 divided by s. Laplace transform of t power of n minus 2 minus 1 is n minus 3, and so on. Also, Laplace transform of t square equal to 2 upon s into Laplace transform of t upon 1. Then Laplace transform of t upon 1, t to the power of 1 equal to 1 by s into Laplace transform of t power of 0. 1 minus 1 is 0. Using all these results by back substitution, we have a Laplace transform of t power of n equal to n upon s, n minus 1 by s, n minus 2 by s, 2 by s into Laplace transform of t power of 1 is 1 by s into Laplace transform of t power of 0. So see here, n minus 1, n minus 2, 2, 1, etc. 2, 1 ಅಂತ ಹೇಳಿದ್ರೆ n factorial. This is s, 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 denominator ಅಲ್ಲಿ s ಇದೆ. How many times? n times. So s power of n. Laplace t power of 0. Otherwise, any value to the power of 0 becomes 1. So t power of 0 is 1. Laplace transform of 1 is 1 upon s. So n factorial into 1 is n factorial divided by here base is common. Index is different, n plus 1, where n is a positive integer. Next, table of Laplace transforms. So f of t ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕಾದ್ರೆ ಲ್ಯಾಪ್ಲಾಸ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಎಗೆ ಎ ಬೈ ಎಸ್. ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಆಫ್ ಇ ಪವರ್ ಆಫ್ ಎ ಟಿ ಈಸ್ 1 by s minus a. Laplace transform of cos hyperbolic of at is s divided by s square minus a square. Laplace transform of cos at is s upon s square plus a square. Laplace transform of sin hyperbolic of at is a upon s square minus a square. Laplace transform of sin at is a divided by s square plus a square. Laplace transform of t power of n is gamma of n plus 1 divided by s upon n s to the power of n plus 1. Laplace transform of t power of n is n factorial divided by s power of n plus 1, where n is an positive integer. ಇಲ್ಲಿ ಸೇಮ್ ಇದೆ ಟಿ ಪವರ್ ಆಫ್ ಎನ್, ಬಟ್ ಗಾಮಾ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಯಾಕಂದರೆ ದಿಸ್ ಈಸ್ ಎ ರಿಯಲ್ ನಂಬರ್, ನಾಟ್ ಎನ್ ಇಂಟೀಜರ್, ರಿಯಲ್ ಪಾಸಿಟಿವ್ ರಿಯಲ್ ನಂಬರ್, ವೇರ್ ಎನ್ ಈಸ್ ಎ ಪಾಸಿಟಿವ್ ರಿಯಲ್ ನಂಬರ್. ಅಂದರೆ ಇಂಟೀಜರ್ ಅಲ್ಲದಿದ್ದರೆ ಈ ಫಾರ್ಮುಲಾ. ಇಫ್ ಇಟ್ ಈಸ್ ಎ ಪಾಸಿಟಿವ್ ರಿಯಲ್ ನಂಬರ್, ನಾಟ್ ರಿಯಲ್ ನಂಬರು, ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ ಆಗಿದ್ದರೆ, ಎನ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ ಆಗಿದ್ದರೆ ಟೇಕ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. Observe the following illustrations based on the table of Laplace transforms. First one, Laplace transform of constant is equal to constant by s. Laplace transform of e power of 2t is 1 upon s minus 2. Laplace transform of e power of minus t. So then a value is 1. So 1 divided by s plus 1. Here minus t coefficient is minus 1. So then a is minus 1. Okay. So Laplace transform of e power of minus t is 1 upon s plus 1. Laplace transform of 3 into e power of 4t, 3 take it outside. Apply the Laplace transformer only here. ಇದಕ್ಕೆ ಮಾತ್ರ ಅಪ್ಲೈ ಮಾಡಬೇಕು. Laplace transform of e power of 4t is 1 upon s minus 4. Then 2 is a constant, take outside. Apply the Laplace transformer for this cos hyperbolic of 2t only. So Laplace transform of cos hyperbolic of 2t is s divided by s square minus 2 square. 2 square is 4. So 3, take it outside. Laplace transform of sin hyperbolic of 2t. So that is 1 divided by, not 1, a. a divided by s square minus 2 square ಅಂದರೆ ಲೈಕ್ a ಸ್ಕ್ವೇರ್. ಸೈನ್ ಹೈಪರ್ಬೋಲಿಕ್ ಆಫ್ ಎ ಟಿದು ಫಾರ್ಮುಲಾ ಏನು ಲ್ಯಾಪ್ಲಾಸ್ದು? ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಆಫ್ ಸೈನ್ ಹೈಪರ್ಬೋಲಿಕ್ ಆಫ್ ಎ ಟಿ ಈಸ್ a divided by s square minus a square. So then a is 2, 3 2s are 6, then 2 square is 4. Laplace transform of cos t is s divided by s square plus 1. Laplace transform of 3 cos 4t. 3 take it outside. Then Laplace transform of cos 4t ಅಂತ ಹೇಳಿದ್ರೆ s divided by s square plus 4 square. 4 square is 16. Next, ninth problem. Laplace transform of t power of 5. So here to the power of n is positive integer. So 5 factorial divided by s power of 5 plus 1 is 6. So 5 factorial is 120 divided by s power of 6. Laplace transform of 4 t to the power of 3. 4 take it outside. T cube. Here this n is positive integer. 3 is positive integer. Take that formula n factorial divided by s to the power of n plus 1. So 3 factorial divided by s power of 4 means s power of 3 plus 1. Okay. 3 factorial is 6. 3 into 2 into 1. So that is 6. So 6 4s are 24 divided by s power of 4. Laplace transform of square root of t. This is so ಇದು ರೂಟ್ ಟೀನ ಹೀಗೂ ಬರಿಬೋದು, ಟಿ ಪವರ್ ಆಫ್ 1/2 ಅಂತ ಗೊತ್ತಾಯ್ತಲ್ಲ. ದಿಸ್ 1/2 ಈಸ್ ಎ ನಾಟ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್. ದಿಸ್ ಇಸ್ ಫ್ರ್ಯಾಕ್ಷನಲ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ಕನ್ಸಿಡರ್ ದಟ್ ಫಾರ್ಮುಲಾ, ಗಾಮಾ ಫಾರ್ಮುಲಾ, ಗಾಮಾ ಆಫ್ n plus 1 divided by s power of n plus 1. So gamma of n value is 1/2. 1/2 plus 1 is 3/2 divided by s power of n plus 1. n value is 1/2 plus 1. 1/2 plus 1 is 3/2. Laplace transform of root t equal to gamma of 3/2. We know the formula, gamma of n is n minus 1 into gamma of n minus 1. So n is 3/2. 3/2 minus 1 is 1/2. Gamma of 3/2 minus 1 is 1/2 divided by s power of 3/2. So ಈ 2ನ ಡಿನಾಮಿನೇಟರಿಗೆ ಬರೀರಿ. Gamma of 1/2 is root pi. So root pi divided by 2s power of 3/2. Next, Laplace transform of sin 2t equal to 2 divided by s square plus 2 square is 4.